Okay, today what we would be learning is Unit 4, Day 1, which is over rational expressions. Day 1 talks about simplifying, multiplying, and dividing. As we go through this, feel free to pause wherever you need. I won't pause as much for you to write things down, so just take care of that on your end. Rational expressions. A rational number is anything that can be written as a fraction. Your expressions then means that I'm going to be bringing in different variables and writing things on top of each other. So it's basically going to be the problems you were given last chapter, but instead now written as a fraction, which is usually everyone's favorite thing. So what we're going to talk about first a little bit is your fraction operations to make sure you remember those, because every single problem we will do in this chapter, if you remember how to do it with a normal fraction, then you are going to follow the exact same rules. It's just going to have to involve factoring and different polynomial rules that you've learned in Algebra 2. So I'm just going to make up some numbers so that we can practice what our different operations would be. So for example, the first thing is if you are going to simplify a fraction. So if I gave you let's see, 8 over 32. What you were taught to do was to figure out if they had a common factor. So in your brain, you're immediately figuring out what goes into both 8 and 32. You don't necessarily write it out every time, but you think those through and you would say, oh, 32 is 8 times 4. And 8 is just really, you can write times 1. What happens is, since this is multiplication and division, those 8's cross out and your answer is just 1 over 4. If one of them doesn't go into the other, let's see, 6 over 4 maybe. So 4 doesn't go into 6, but your brain does kind of the same thing and figures out what goes into both. You'd say, oh, 6 is 2 times 3. 4 is 2 times, oopsies, sorry. 4 is 2 times 2. So those 2's cross out, again, once it's all multiplication and division, and your answer is 3 over 2. For multiplication and division, oopsies. You got some similar rules. If it is multiplication, you're doing, say, 1/4 times 2/3. And what you would do, if you think back to when you learned this, is you multiply straight across. So you do 1 times 2 is 2, 4 times 3 is 12, and then you go through this same simplifying process. So you would say, okay, what goes into 2 and 12? And whether you write this out or not is different. You'd say, oh, 2 goes into both of them, so 2 times 1, 2 times 6, those 2 crosses out and it's 1 over 6. Again, at this point, usually by the time you make it to high school, you don't necessarily write out the 2 times 1 and 2 times 6 that I have right here, but that's how you were taught originally way back when. The last operation we're going to do today is division. And say I make it the same problem, 1 over 4, but now it's divided by 2 over 3. What you learned way back when was that dividing by a fraction is the exact same as multiplying by the reciprocal. And we are actually going to get into that in more detail later this chapter, and I'm going to show you really why that works, especially with way uglier fractions. But for now, we're just going to go with the rule that you were taught forever ago. But then you've turned this into multiplication, and you can multiply straight across. So 3 times 1 is 3, 4 times 2 is 8. You think about if you can simplify 8 and 3, you can't, so that's done. As long as you can do these 3 problems and you can factor, you can do everything we're going to do today. But you always are going to have to bring it back to, how did I simplify regular fractions? Remember, with simplifying these, it had to be multiplication. That's going to be crucial. Multiplication and division, you multiply straight across. Division, you multiply once you flip that second fraction. Okay. So I'm going to give you some steps for these. When you simplify, first thing you're going to do is to factor anything you can. Okay. With this problem, it's a monomial over a monomial, so this is actually very similar to the one we just did. So you can't factor anything, and that's okay. In step 2, oopsies, you are going to divide out your common factors, just like we did before, where I would cross out whatever number was both on top and bottom. The super important thing that I will keep going back to all chapter long is they have to be common factors. So if it is not multiplication between the factors, you cannot do it. Okay, here we're dealing with monomials just like before, so it is very similar to before. 20 and 14, let's see, 2 goes into both of those, so this would be 2 times 10. Again, if you're writing it out the long way, 2 times 7, let's see, that's a 6. The 2's cross out. With your variables, if it is just a monomial, you're following your exponent rules. So 6 minus 2 here would be x to the 4th, and then it's just 10, x to the 4th over 7. The last thing that you have to do, and this is going to be super important the further into the chapter we get, so I like to make you do it from day one just so that you're used to it, is identify your excluded values. And what that means, if any part of your fraction had a denominator, had division, any part of your fraction that was in the denominator was division. If that turns into 0, you can't have that because we mathematically cannot divide by 0. This is going to be super important when we solve equations as well as when we graph equations, because that's part of your domain when we're talking about it of what you cannot have for x. That's why I want you to start doing it now. I cannot have any x value that would make that denominator equal 0. So for your excluded values, you are always going to take your original denominator, not your ending one, set it equal to 0 and solve it. So in this one I would divide by 14 and get x squared equals 0, and that just gives me x equals 0. So how you're going to write that in your answer is you're going to tell me that's my expression, 10x to the 4th over 7, but x cannot be 0. If x is 0, I have a problem. And I'm going to show you when we get to equations and graphing how you show that problem. So this whole thing is your final answer. Okay. This is one that's going to be more representative of how we do this the whole time. It's a little more Algebra 2 level. So with this, we start again by factoring. So when we factor this, the top is not factorable, so I'm just going to leave that as y plus 8. But the denominator is factorable. So you are multiplying to negative 48 and adding to positive 2. I want you to take a second to factor it. I will give you the hint if you need it that it's 8 and negative 6. And I'm going to factor it in my head because I can, and I know it's going to be y plus 8 times y minus 6. Okay, now we have to divide out our common factors, and what's important to realize is that the top is really just this factor times 1. So this is all multiplication, because within the factor, I don't care if there's addition and subtraction, it just matters that the whole factor is multiplied by something. And in the denominator, it's a factor, this y plus 8 times another factor, y minus 6. So everything is multiplication. Then I can divide out any common factors. I have this y plus 8 on top and bottom that I'm going to cross out. What that leaves on top is just a 1, and on bottom is a y minus 6. So that would be my actual answer. And then I'm going to find my excluded values. And you find your excluded values, again, by setting your original denominator equal to 0. I'm going to take my factor denominator, because I know if I'm going to set things equal to 0 to solve, I need it factored anyways. And this would tell me that y plus 8 equals 0 and y minus 6 equals 0. Solving each of those, you get that y cannot be negative 8 and it cannot be positive 6. Either of those values will make it equal 0 in the original problem. It is not just your final answer. It's in the end, in the beginning, would it have made your denominator 0? If it would, you throw it out. The most common misconception is that people want to cross out these y's originally. You cannot do that no matter where or how the y's show up. It has to be an entire factor. So this yellow part is crucial to what you're doing here. Make sure you factor everything before you simplify anything. Write this one down and give it a try. If you want me to work through it first, that's fine. If you want to pause it and try it by yourself, that's perfect. Again, I'm not really going to pause, so you are welcome to do that. On both of these, we're going to factor the top and the bottom this time, the numerator and the denominator. What I noticed right away is I can GCF both the top and the bottom, so it's r squared minus r minus 20 over, let's see, an 8 comes out of there, r plus 4. Then I still can factor the top, so you're multiplying to negative 20, adding to negative 1. It's going to be negative 5 and positive 4. Take a second to actually factor that, but I will tell you that it will result in r minus 5 times r plus 4. Now the whole numerator is factored. This is 2 times a quantity times a quantity. This is 8 times a quantity, so everything is multiplication, and as long as the factors actually match, we can cross them out. So looking up top, I have an r plus 4 and an r plus 4 that can go away. I also have this 2 and 8 that can simplify just like you've been simplifying since you learned how to. So both of them have a factor of 2 that divides out. Means on top you have just an r minus 5, and on bottom that's just a 4. To do your excluded values then, you would do, let's see, 8 times r plus 4 equals 0. This 8 equals 0 doesn't give me an answer because there's no variable. R plus 4 equals 0 tells you that r cannot equal negative 4. Again, go ahead and try this one. There is a trick to this one, which is why I've picked it. So make sure that you look for that as you're working through it. What I noticed right away is my numerator is a difference of squares, so I can factor this as p minus 7 times p plus 7 without actually having to do my factor diamond. It makes my life a little bit easier. What you should notice at this point, right now I have 2 very similar factors, but they have opposite signs. If it helps you to rewrite this denominator so that the p's first, this would really be negative p plus 7. And again, that makes it even more similar to this first one because the p is negative and this one's positive. The 7's negative and this one's positive, so they're exact opposite signs. What we did previously when that happened, when we were factor by grouping is where you saw it before, is we said, oh, if I pull out a negative, it's going to flip both those signs, and that still works here. So I can pull a negative out of the bottom, and it will now have them actually match. So make sure that even with the signs, they have to match perfectly. So if you have to pull out a negative, do it. That's fine. Then my p minus 7's cross out, and this is p plus 7 over a negative 1, which if I divide that all the way through is negative p minus 7. Then for your excluded values, you can set your original or your factored version equal to 0. 7 minus p equals 0. It's going to give you that p cannot equal 7. Okay, when you multiply, it's going to be pretty much the exact same thing. You just have to remember your multiplication rules from before. When you multiply a rational expression, first thing you do is multiply straight across. And I don't necessarily recommend actually multiplying the numbers. What I just remember is, hey, these are multiplied, so it's really one big fraction all the way across. Okay? Why I don't multiply is because I know I'm trying to simplify. So I'm not going to waste my time trying to deal with those numbers and doing 6 times 10 was just going to blow my numbers up when I know I'm going to simplify anyways. But how you do it is totally up to you. Then, oopsies, you're going to factor anything you can. And once you factor, it's going to turn into a simplifying problem. Go away. So you're going to follow those steps from before. So here I can't simplify, or I can't factor anything, so I'm just going to simplify. And what I just like to do is say, okay, let's see. 6 and 2, it's really going to turn into a 3. I know these x squareds will cancel out. These y squareds will cancel out. 8 and 10, I can simplify a 2 out of both of those. This will be a 5. On the bottom, that will now be a 9. And let's see, I have an x cubed on top. y to the 4th over y squared will just be y squared on top. And then I can see that I can simplify even again. This 9 and 3 will simplify down to just a 3 on bottom. So this is 5x cubed y squared over 3. Since this is all multiplied, you could have simplified any way you wanted. So right off the bat, if you notice that 6 and 18 go into each other, you could simplify that and get the 3 right away. 10 divided by 2 is 5, so whatever way you want to simplify is fine. If it helps you to multiply first, perfect. Okay, then lastly, you do want to find me your excluded values. When I do that, again, you take your denominator and set it equal to 0. So it would be the 2x squared y squared equals 0 and the 18 y squared equals 0. Solving either of these, it's just going to give you y cannot be 0 and x cannot be 0. Okay, this is going to be what most of your problems look like, if we're being honest. But it is no different than what you did before. So what I like to always remember, again, this is multiplication, so this is really just everything on top times everything on bottom. So it really just means when you simplify, you can simplify from wherever you want. What you need to do then is actually factor everything that you've got there. So I'm going to go through and factor these. If you want to pause it and then just check it when you're done, that's fine. On top, let's see, I can GCF that first numerator, so that's 4x is going to be x minus 1. On the second one, you're going to factor diamond that. It's negative 6 and positive 1, which is 3 and negative 2. Sorry. And I know that that's going to be x plus 3, x minus 2. But again, go ahead and fully factor that to make sure you agree with me. This one over here, you can GCF first. So if it helps you, you can just write that small below. I'm going to just do 2. This is the x squared plus 2x minus 3. And then I'm going to factor diamond that. So you're multiplying to negative 3, adding to 2. It's 3 and negative 1. Again, factor it all the way out. Make sure you know how I got x plus 3x minus 1. Last but not least, I can GCF that last one. So this is times 4x times x plus 2. Okay, once you have all of that, then you can go through and start to simplify however you want. If you want to multiply like this 4x times 2, you're more than welcome to. You just don't have to. What you're focusing on is what you can cross out. So like I notice right away that I can cross out the 4x's altogether because they match completely. I have an x minus 1 that I can cross out. I have an x plus 3 that I can cross out. You cannot cross out these because one's minus and one's plus. So that means that on top I will have x minus 2. On bottom you have that 2 that's out front, and then x plus 2. You can leave that factored or multiplied out. It really doesn't matter. But that would be your answer. Then you have to find your excluded values, and that has become a little bit longer, because you have to set all of the denominators. So 2 times x plus 3, x minus 1 equals 0, and you're setting 4x times x plus 2 equal to 0. So from this x plus 3, I get x cannot be negative 3. From x minus 1, I get x cannot be 1. From 4x, I get x cannot be 0. And from x plus 2, I get x cannot be negative 2. And that's your final answer. Same thing, go ahead and try this one. Pause it if you need to, and then I will go ahead and do it. When I factor that numerator, I'm going to pull out, let's see, I can GCF this first, and it'll be 5v is 2 minus v. The denominator right here, multiplying to 18, adding to negative 11, is negative 9 and negative 2. Multiplying this over, factoring this over here, you're multiplying to negative 9, adding to negative 8, so it's negative 9 and 1. And then again, finish factoring it, make sure you agree. Whoops, gotta write the right variable. That 15v I can't factor, so I'm just going to leave it. So then I go to cross things out. V minus 9's cancel. I notice again I have this similar problem to before. These are the same as long as I pull out a negative. So what I'm going to do is make this 5v negative, which makes my 2 negative and my v positive. Now I divided a negative out of both terms. Even though they're written backwards, they're the exact same thing. So now I can cross these out. Looking at the 5 and the 15, that really becomes a, 3. And my v's cross off. So now I need that negative. I have a v plus 1 on top, and I have a 3 on bottom. You can also write this, you can distribute that negative 3 if you want. Negative v minus 1 over 3. Either would be perfectly fine. For your excluded values, you do v minus 9, v minus 2 equals 0, and you do 15v equals 0. So v cannot be 9, 2, or 0. Last example is of division, and division again works the exact same way as multiplication. I'm just going to remind you what you have to do. And it will always, like we said before, go back to how you learned how to divide and multiply and add and subtract fractions originally. When you are dividing, remember that you are going to really just multiply by the reciprocal. So you are going to flip your second fraction so that you are multiplying by the reciprocal. And this will let you multiply. So I'm going to rewrite this originally. 2a cubed minus 12a squared over a squared minus 4a minus 12 is now times this a squared minus 8a plus 15 goes to the top, because that's how you find your reciprocal. You flip it over. And then 24a squared minus 8a cubed is now in the denominator. Then the process is exactly the same as what we just did. So you are going to factor. So on top, let's see, I can pull out a 2a cubed. So it's going to be a minus 6. On bottom, you're multiplying to negative 12, adding to negative 4. So that's going to be negative 6 and positive 2. Over here, you're multiplying to 15, adding to negative 8. So negative 5 and negative 3. And then in bottom, I can pull out an 8a squared. Let's see, and that'll leave me with 3 minus a. Then you can go ahead and simplify. Let's see, the a minus 6 is crossed off. The 2 and the 8 will just become a 4 in the denominator. A squared cancels out and just gives me 1a on top. And this a minus 3, again, I can, as long as I pull out a negative, so I'm going to put a negative here by the 4. The 3 is negative, the a is positive, and now those cancel. So my answer, let's see, I have an a times a minus 5 over negative 4a plus 2. So this is kind of an uglier answer, but that's fine. Oops, just realized I pulled out one too many a's up here. I apologize. So this would have been a 2. And so then the full thing would have crossed off. So it's just a minus 5. Sorry about that. That negative 4 you can distribute through. You can pull the negative through the top. You can put that a lot of different places. I'm not going to be particular about that. Your last step, like before, is your excluded values. Things that cannot be. Again, this is going to be super important for your domain later on. But it cannot be, if I just look at it since I'm running out of space, a minus 6 means a cannot be 6. A plus 2 means it can't be negative 2. 8a squared means it can't be 0. a minus 3 means it can't be 3, and the hard part here, because this is division originally, you have to include this entire second fraction. So I'm also going to look at the numerator right here. So I've done all the denominators, but I need the numerator of my second fraction because it was originally division. So if any part of this second fraction is 0, then it means I'm dividing by 0. So I'm also going to look here. So that means, whoopsies, that 5 is also an excluded value. And that's it.